Hello students. Welcome to today's science class. In this video we are going to learn some very interesting ideas about matter, things you see every day but maybe never understood. We will talk about liquid crystals, sublimation, and how substances heat and cool. I will explain everything in very easy English, slowly, clearly, and with real-life examples so even weak students can understand perfectly. Let's begin. Matter normally exists in three main forms: solid, liquid, and gas. You know this, solids have fixed shape, liquids flow, and gases spread everywhere. But there is something very special called liquid crystals. Liquid crystals are surprising because they are not completely liquid and not completely solid. They are in between. They flow like liquids, they can move and change shape, but inside them the particles are arranged in an ordered way, like they are in a crystal. So they behave partly like liquids and partly like solids. You might think this is strange, but liquid crystals are actually part of your everyday life. Every time you look at your mobile phone, laptop, TV, calculator, or digital watch, you are looking at liquid crystals. These screens are called LCD screens, the full form is liquid crystal display. Liquid crystals are special because they can block light or let light pass when electricity is applied. This makes it possible for the screen to show numbers, pictures, colors, and text. They are also used in some thermometers that change color with temperature. When the temperature rises, liquid crystals change their arrangement, so they reflect different colors. Now let's talk about another very interesting thing: sublimation. Normally, when you heat a solid, it melts and changes into a liquid. Then when you heat the liquid, it boils and changes into a gas. So the usual order is solid convert into liquid which convert into gas. But some substances skip the liquid step completely. When you heat them, they change directly from solid to gas. This process is called sublimation. A very famous example is dry ice, which is solid carbon dioxide. If you touch dry ice or see it in movies, you see fog or smoke. But that smoke is not water vapor, it is carbon dioxide gas coming directly from the solid. Dry ice does not melt into a liquid, it jumps straight to gas. Another example is iodine. It is a shiny purple solid that changes into purple gas when heated. We also see sublimation in our homes. Mothballs, naphthalene balls disappear after some time. They do not melt, they sublime. Now let's understand something very important: what happens when we heat a solid like ice. Scientists draw a graph called a heating curve. This graph shows how the temperature changes when a substance is heated. Imagine we take ice at -15 degrees Celsius and we heat it slowly. At the beginning, the temperature rises from -15 degrees Celsius to 0 degrees Celsius. So you have only ice, just getting warmer. But when the temperature reaches 0 degrees Celsius, something interesting happens. Even though you continue heating, the temperature does not rise. It becomes flat, it stays at 0 degrees Celsius for some time. Why? Because at this point the ice is melting. The heat energy is not making it hotter, the heat is being used to break the attraction between the water particles in ice. The solid water is turning into liquid water. During melting, the temperature stays exactly the same until all the ice has melted. After all the ice has melted, now we have liquid water. When you continue heating, the temperature rises again, from 0 degrees Celsius up to 100 degrees Celsius. This is the heating part for liquid water. At 100 degrees Celsius, the same thing happens again. The temperature stops increasing. The line becomes flat again. This is the boiling point of water. At this stage, water is changing into steam gas. Again, all the heat you add is used to change the state, not to increase temperature. After all the water becomes steam, the temperature can rise above 100 degrees Celsius if heating continues. An important point for exams. A pure substance has a sharp melting point, it melts at one exact temperature. If there is an impurity, like salt mixed with ice, the melting point becomes lower. That is why salt melts ice faster. Cooling works the same way but in reverse. If you cool steam, it stays at 100 degrees Celsius while it condenses back into water. Then water cools from 100 degrees Celsius to 0 degrees Celsius. Then at 0 degrees Celsius, the temperature stays the same while water freezes into ice. After freezing, the ice cools below 0 degrees Celsius. During condensation and freezing, energy is released. Now let's answer the questions. Memo questions. 1. Write down as many uses as you can for liquid crystals. Answer. Liquid crystals are used in mobile phone screens, laptop screens, TV screens, calculator displays, digital watches, car dashboard screens, color changing thermometers. 2. Why do gases expand more than solids for the same increase in temperature? Answer. Because gas particles are very far apart and move very fast when heated. They have lots of space to spread out. Solids have particles packed close together, so they cannot expand much. 3. Ice on a windscreen disappears while driving, even without the heater. Why? Answer. Because the ice sublimates. Air blowing on the ice helps it change directly from solid to gas, so it disappears. 4. When salt is placed on ice, the ice melts. Why? Answer. Salt lowers the melting point of ice. So even at temperatures below 0 degrees Celsius, the ice melts. 5. Draw and label the graph when water at 100 degrees Celsius is cooled to -5 degrees Celsius. Answer. The graph should show. Start at 100 degrees Celsius, steam. A flat line at 100 degrees Celsius during condensation. A downward line from 100 degrees Celsius to 0 degrees Celsius as water cools. A flat line at 0 degrees Celsius during freezing. A downward line from 0 degrees Celsius to -5 degrees Celsius as ice cools. Thanks for watching. Like and subscribe to my channel.